everybody, it's old SHAZIZZ here. This is probably going to be one of my most important videos for you to pay attention to on this deal here. In my last video, I showed this right here, which is a little generator that I made out of a microwave carousel and a 12-volt motor out of a blend door actuator out of a I think it's a Mercury Mountaineer. Anyway, showed you what you could do with that deal right there, and I told you there's a little bit more to what was going on there than meets the eye. And so this video right here, it will hopefully give you a little bit better understanding of what was happening. But this deal that you're looking down here, this is a flyback transformer that I took these ferrite cores out of. And the coils that you see right down in here, these came out of these microwave oven fans. You take bend this far enough and these just slide right out, and that's what I made the cores for. And so I'm gonna do a lot of moving around with the camera and some voltage measurements and stuff that I want you to pay attention to. And let me give you a little bit closer view of what I got going on here. Alright, this is a really simple circuit. I'll try to post a link to a picture of this. It's a Mosfet flyback driver. I use the IRF Z44 Mosfet, a resistor, and it's got a center tap on the coils. That's what you see right here. There's a center tap on this coil. There's 12 turns with a center tap. And over here, where's that? I gotta figure out how to get this thing to move. Where's it at? There it is. Alright. Over here, I have the same motor controller that I use to run this little generator. Right here. Alright, and let me see if I can get you a side view down in here. This has a coil right here and one right here, and these are two of the, I basically made legs with this one here to make the ferrite core be able to come in contact with the metal laminates that are inside there, basically to guide that magnetic field there. So you got a coil down here and you got a coil over here. Now let me get this all organized here. So basically what's going on here is it's energizing two cores using a MOSFET and a motor controller to actually adjust the voltage input, which in this case is going to be a 9-volt battery. And I'll show you something about that whenever I get to running the first portion of the test. But nonetheless, this coil right here, you bring it up. I told you I'm going to have to do a lot of moving around in this video. Sorry about that. Alright, this coil right here is running the same version of the bridge rectifier that was in the last video. And one of the AC legs is on one side and the other AC leg goes to a capacitor over on this side. And this is really important. I need you to pay attention to this part so that there ain't no misunderstandings what's going on. This voltmeter right here is actually part of this circuit. Alright, the circuit board in that voltmeter is what is allowing the energy to actually flow through the voltmeter back out and charge this capacitor right here. So the circuit board inside that is part of the entire system right there. And this is the AC side. It's set on 200 volts AC, and this is the DC side. On this same On the DC side of this rectifier, there's two 25 or 50 volt capacitors, whatever I said they were in the last ones. It's not important right at this point in time. But either way, there's two of them ran in series that are on the DC side, and so you're going to get the voltage measurements over off of that side. Now, right down here is a wireless circuit. I'll try to hold that steady, kind of get a general idea how it's going. I need to actually draw a diagram of this so people can duplicate it, but that's important as well. And I'm gonna put it up close to it. Right about there ought to be good enough for a moment. Alright, so that's a wireless circuit, and right down here is a bulb that I believe, let's see, it's not helium, it's not argon, neon, I believe it is. Anyway, I'll have to figure that out for sure. Either way, it's one of the noble gases. It's the orange color. I can't remember right at the moment. But that is being run off of this transformer on the side. Right now, that's its only purpose. So basically what you'll see is a high voltage at high frequency that's able to literally energize the gas inside there and light this bulb up. And so with that said, you'll get a wireless energy transfer to this circuit right here, which will light these two LEDs up and charge these little capacitors. And you'll get a voltage reading on the other side, and you'll be able to see this capacitor here charge. And so with that said, let me bring this up a little bit and try to get the voltmeters in view. Alright, and so let me see, I might scoot back here. Maybe I'll go higher. Trying to get everything in there. Once again, no shenanigans. You know, I been kind of taking a lot of heat behind the scenes about people want to be wise guys about things that I'm trying to show people, but this is something that if you try at home, you're gonna know there ain't no trickery to this. This is such simple science. It's really ridiculous, and it doesn't defy any of the known laws of physics. And for those folks that want to jump in there and try to quote the laws of thermodynamics, don't even waste my time with it, because the laws of thermodynamics don't even apply. We're not trying to make a closed loop system, and we're not trying to get over unity. We're not trying to get 0 point. We're not trying to, get out more that we're putting in or anything like that. We're not trying to defy any laws of physics. So the thermodynamics shenanigans that I keep getting cursed at about, mouthed off at, you're wasting your time, you're wasting my time, and you make yourself look foolish when you start trying to sound intelligent and quote the law of thermodynamics, because what's going on here has absolutely nothing to do with that. This is a frequency range experiment which basically shows how to use electricity in a completely different manner than what we are accustomed to. And none of your measurements, your current watts and your amps, none of your measurements are going to apply until after the stage when we decide to start using them on the inefficient appliances on the opposite side. When you start dragging voltage off the output, then you can start your measurements again. But in this system right here, you can't measure it the same exact way. The same exact math doesn't apply. The only reason why these voltmeters are even functioning in this process is because they're registering voltage alone, and that's all I've ever cared about, and that's what I've been trying to explain to people. Voltage is what matters. Voltage is pressure, and that's how you get things done. I did this video called Physics Toy. Alright, this one little toy right here will show you vacuum, it'll show you pressure, it'll show you basically how a capacitor works, how you can store energy. And then whenever you want to use that energy, you basically flip the switch and turn it on, and there you go. You know, you have stored pressure. So go see my video physics toy and you'll understand what that's all about. But that is to explain what's going on whenever you're putting voltage at a specific frequency to this circuitry. You're going to see several things happen. You're going to see an AC capacitor get charged. You're going to see a DC capacitor get charged. You're going to see this coil right down here energize the noble gas into the fourth state of matter, being plasma. And you're going to see a wireless energy transfer. And it's all going to come about from the energy potential of this 9-volt battery. And so if you're willing to listen to me and humor me long enough to understand what it is that I'm trying to show people, then I'm sure that you will understand why it is that I'm saying that you can do something completely different with electricity, and you're not getting out more than you're putting in. You're putting in what you're using, but you're using it in such an incredibly efficient manner that you're able to get much more work done for a lot less input. And the problem that we've had with our so-called energy grids and the so-called energy crisis is that it's not that we don't have enough energy, it's that we're not using it properly. And if I show you this and you understand what it is that I'm pointing out to you, and you understand what's going on, then you'll understand how to build new systems that you can literally store massive amounts of power and be able to run, you know, things that you didn't think was possible to run before, using all the existing technology on the store shelves. And so with that said, I'm going to go ahead and turn this on, and I'm only turning this motor controller on until I get this light to light up. Once I get that light to light up, then I'm stopping in that range right there. Alright, there you go. Now I'll go flip the light switch off so you can see that blinking. You can probably see it blinking already, but I want to make sure that you see that they're actually lit up. It's kind of crowded in here, so sorry about bumping things around, but I have to do this. Alright, you can definitely see that they're lit up. Okay, so now where do we go to from there? Sorry about that. Alright, now if you notice the voltages on the voltmeters, see if I can get a little clearer. We just barely got this thing turned on right now. Alright. Now I'm going to bring it up a little bit. And you see, I just went, look at the voltage range on the AC side. Alright. See it fluctuating between 40s up to even in the 100 range. You see that I've got 20, 30 volts going on right there and rising. And you'll see down here that I still have this, and I still have the wireless going on right there. And so let's see if I can get this going here. Like I said, I barely got this motor controller on. I'm using it to regulate the input of the battery. You see the numbers going across the voltmeters. This is the AC side, this is the DC side. Now I'm going to bring it up again. Look at the voltage range right there where we're at. Now we're changing frequencies. The higher we bring this up, the more we're changing frequencies. And eventually you'll start to hear a ringing going on down in these coils. I don't think the camera's picking it up right now. And then you'll actually get out of range at some point. But you can adjust it back down. We're going down now. It's almost all the way off there. And just barely on right there. I'm going to keep going until I get that adjusted just right. want, there we go, right there. Alright, now my voltage dropped down. I'm right there at that specific frequency. I'm turning it up just a hair more. And keep in mind, this is a 9-volt battery we're talking about. Alright, I'm going to turn that off now. Now I want you to watch this right here. It's a capacitor. Did you see that? And watch this right here. Did you see that? Alright, we just took energy from a 9-volt battery. We charged an AC capacitor. We charged a DC capacitor. We energized a fluorescent, not a fluorescent bulb, I think it's neon bulb. We energized the gas inside there into plasma, and we got a wireless energy transfer. Now I'm gonna take this battery that you see right here in front of me. No shenanigans going on whatsoever. I'm holding it right here. This ain't no kind of trick or anything like that. I want to show you something. Okay, I got trying to get my wires up around here. It's right there in front of you. It's not moving anywhere. I'm not trying to do any kind of faster than the hand tricks or anything like that. But I want you to check this out. There's the voltage of that battery. Right there. That's how much power was in that battery when we were running that. Now, people can say whatever it is they want to say. I've been called many things. Been told I was stupid. But you just seen me do this. And if you understand the implications of what it is that I just showed you, then you'll know where to go from that point on. Okay, so I'm going to try to adjust this back again till I get both my bulbs on. Right there. Now I'm getting wireless energy transfer. I'm getting that voltage from the AC side. And then I'm getting this voltage over here. You got to be careful because the other day I shocked the crud out of myself doing this. Alright. That all came out of that battery right there. Now for those folks out there that say that I'm stupid and I don't know what I'm talking about, you know, sorry about your luck if you don't understand what I'm saying. And if the laws of thermodynamics is going to be the cage that you live in, then you're never gonna get any further than what you've got so far. Right now we have more energy than we could ever use in 1 trillion lifetimes, and if used properly. If you took this concept right here and the circuitry that's inside of that right there, what just so happens is able to take this specific frequency and allow it to charge that capacitor, and this bridge rectifier, which takes this same frequency and still recognizes and charges that DC capacitors over there. You've got plasma going on. You got wireless energy transfer happening. And back this thing down again. You can actually sit there and you can adjust. You can adjust your power. Now I can take this battery off and let's take and get another measurement on this battery right here to see if it's any more power whatsoever. Okay, this one's about 8 volts. Alright, let's see what we do with 8 volts. See if it makes any difference whatsoever. I'm telling you folks, all I care about is voltage. I couldn't care less about current, watts, and amps. And did you see that right there? 8 volts. A little bit more power and you watch the thing light up better. And we can actually adjust the voltage I just went on the high side there. It's really super sensitive, but you find the right frequency range. Look where my DC voltage is right there. All right, and then you'll hear this thing begin to ring down here. I don't think you can hear it on the deal. Oh, I just blew my meter. Look at that. That capacitor, this capacitor right here. Nope, I didn't blow the meter, but look at this. That capacitor right here discharged into that right there. That's what that, you can see the spark, the arc going across there. And how it didn't blow that fuse inside that thing, I have no idea. But let's see if I get any voltage again. There's that one charged. I may have blown that. I don't know. I don't know if you can hear that ringing. Yeah. I think I blew the circuit inside there. Well, let me test that doggone. Switch that over there and see if that ding thing is still alive. That was a pretty good sized pop inside there. Yeah, I killed it. I killed it. Oh, no, wait a second. I was on the wrong one. Yeah, I better go try that one. This is the one I need. And that one. Yep. Nope. It's that loose connection. Imagine that. Boy, that's good. Alright, well, that's pretty much what I wanted to show you. And you seen it right there. You saw me discharge those capacitors. You saw me charge them up. You saw the voltage on the deal. And you'll be the judge from that point on where this is all leading to. I just gotta shorten that wire. Yeah, these are little cheapo meters, so anyway. See if I got any juice in there. Yep, a little bit. Alright, well, that's it, folks. Peace and love. I'll get this video up and put your thoughts down in the comment section. Look, I've told everybody, I don't know how many times, if you ever want to talk to me about a project or whatever, I'm easy to get a hold of. Add me as a contact on Skype. Jump over there to SHAZIZZradio.com in the super chat, drop in a message, and ask me personally. You know, you don't have to give me, a hard time and tell me how stupid I am. I don't know physics or whatever like that. I just showed you a physics toy that I put together. I do understand physics. I understand science, and I understand that we are literally using energy in the wrong manner. And so I got a whole lot more to explain to you on how all this stuff is functioning, but you just saw what I just did. So with that said, you be the judge of that. I know where I'm going. Peace and love, everybody. Take care.